Hi everybody. My name is Hüseyin Demir. I work as a senior database platform engineer in Trendyol.com. Trendyol is the largest e-commerce platform in Turkey. In addition to this, I have worked with different database platforms like PostgreSQL, Couchbase, Cassandra, and MS SQL. Nowadays, I'm working on Yugabyte database. In this presentation, I will try to explain what was our requirements for our company and how we met Yugabyte. So let's start with the agenda. The agenda includes about Trendyol part and technical and business requirements parts. After that, we will study what is missing in our current tech stack and our project requirements. After that, we will continue with the how Yugabyte DB meets our needs. And finally, we will study our architecture, benchmark results, and when to use Yugabyte DB parts. Finally, we will talk about our feature plans for the Yugabyte DB. I think we are ready to start. So about Trendyol, Trendyol is the largest e-commerce platform in Turkey. 45 million mobile downloads to date, more than 40 million visits in a month. After that, more than 6 billion visits in the last years, and more than 3,000 million products sold in last year. Trendyol is a technology company first, priority for campaigns of SMAs that are focused on digital transformation. So this is our company. So we can study with the requirements part, the technical requirements for our projects. Our requirements were very specific and important. All the requirements were needed to be satisfied simultaneously, and so we had no chance to discard one of them. Our systems or the database infrastructure has to be high available in a first part. So we needed a clustered architecture inside one data center, because Yugabyte has no traditional master-slave model. We are able to use all nodes in the cluster in order to accept read and write requests. We will talk about the importance of the distributing write request later, but in our projects and in our mission, the distributing the write request is very important. One of the most important key factors, actually indicators actually. Secondly, scalability was very important for us in traditional relational databases. We are not able to scale our infrastructure by adding new nodes to the cluster regarding sharding. The third one is about cloud native platform. The operational load on administration task and deployment task were very high and expensive for us. So we needed a database platform that can which can be managed as a service practices regarding cloud native platforms, because we are running on-premise environment. So this is also important. The last two part is about multi-region deployment options and the replication features. Because of some business needs, we had to provide multi-region deployments. Database infrastructures was supposed to accept write requests on two regions simultaneously. This was our technical requirements for our projects in order to achieve the mission. So, but we considered some options and tried the other solutions also. So we decided that we saw that there were some differences and there were some missing points. When we consider when we consider with the high availability, we studied the other database solutions for our specific projects. The high availability part was different between other solutions and the Yugabyte. So in Yugabyte, we are able to support high availability in 2 or more data centers at the same time. When it comes to scalability part, other DB solutions that we consider for this projects are able to scale vertically, but Yugabyte is able to scale in a horizontal way. So the cloud native features are also different. So in Yugabyte, it's fully supported cloud native database platforms. When if you use in on-premise also, multi-region deployment options are also fully supported in Yugabyte. The last part is about replication. In this project, we needed bidirectional replication, active replication. The other database solutions that we consider for this project are not supposed to do bidirectional replications between 2 data centers. So we completed our proof of concepts and research in order to decide what can we do. After this part, this is exactly where we encountered the Yugabyte database. We decided to use a database platform which is capable of distributing data among servers in an equally. Yugabyte can be used to achieve this goal. Actually, Yugabyte is a database platform, as we mentioned before, that can scale horizontally and distribute the data between tablet servers. So we will also talk about tablet servers, but the tablet server is responsible for storing data in terms of Yugabyte database. This is a very specific keyword, the Yugabyte. As we said, Yugabyte is a distributed SQL database, and it's a PostgreSQL native database platform, and possible to use all features belonging to PostgreSQL because it uses open source PostgreSQL engine also. So we studied at this point. We studied what was our requirements and what are the other solutions and how we met Yugabyte, how Yugabyte solves our problems. But when it comes to scaling, we have to talk about what's cool in scaling for Yugabyte. So the features and the options are very useful for us when we use Yugabyte because Yugabyte solves our problem by distributing data between Yugabyte database tablet servers, and it supports multi-regional environment. So we are able to handle user request both read and write request at the same time on 2 different data centers. So it's very pretty cool actually with scaling parts. When you have to select relational databases, transactional relational databases, sometimes it's very hard to scale in a horizontal way and accept the write request simultaneously. This can actually make your this can force you and actually encounter some problem. This leads to you encounter some problems. Can we stop recording? As we talk about scaling for our requirements, so what's cool in scaling for Yugabyte DB? Yugabyte DB solves our problem by distributing data between Yugabyte DB tablet servers, and it supports multi-regional environment. So we are able to handle both read and write request. Handling the write request is very important. So we also worked with Yugabyte for this purpose and complete some proof of concepts actually. So after all, proof of concepts and researches, so comparison tables. So we created our current Yugabyte architecture. We built our current Yugabyte DB architecture. So due to our needs, we need to meet user requests in multiple regions, as we say. User requests included both read and write requests. So in order to meet this need, we installed two different database clusters in two different data centers with the Yugabyte DB platform and performed replication operational. It's bidirectional replication between two data centers. By doing this, any data change request from any data centers are directly replicated to the other data centers. So this is very cool and useful setup for us. This architecture solves our main problems. So maybe we can also study the performance considerations. We can also study benchmark results. We compared another solutions to the Yugabyte, but after all findings and determinations, we performed some benchmark tests and stress tests to evaluate our own acceptance criteria conditions for Yugabyte DB. However, it should be noted that we conducted these tests specifically for our own purpose, for our own projects, and we created our environments with this specific purpose. So we assumed that the results are very specific to our project. So whenever you need to create some test like that, you have to think about your requirements and environments also. As can be seen in the table in the presentation, these are the variables we use for the test. The metrics we base on this test can be explained as the total number of transactions, the total number of records, and the total number of threads. For the results, we used the total elapsed time in order to complete these operations and records, transactions, the average number of operations per second. So with these two result set, we made our findings and comments according to the results. So let me show you let me show you a simple result. As the results imply, Yugabyte DB can handle more transaction per seconds. Also, Yugabyte DB is performing better under heavy load in terms of select and update requests because we are able to distribute our select and update requests among the Yugabyte DB servers. This was our performance consideration and benchmark results. Maybe we can talk about when to use Yugabyte DB or how can we select the Yugabyte DB. The most important reason for choosing Yugabyte database is that it can work as distributed. In addition to this, Yugabyte DB can meet high amount of OLTP loads, can meet OLTP loads simultaneously in multiple geographical regions. In addition to this, it follows the ACID rules like traditional transactional relational databases. So this is very cool about Yugabyte. For the future plans, we studied with Yugabyte databases and we discovered its powerful features. So we are able to we will use the Yugabyte for our next projects and for our next high scalable environments, for our next high scalable projects. So I think we will also distribute the Yugabyte deployments in our other projects also. So this is the presentation. I hope you enjoyed listening. Thank you so much.
Thank you, Hussein, for that awesome presentation. Folks, I hope you found the session informative. I want to leave you with a few resources that we have that you can go and check out if you're interested in deep diving into performance. First thing, please check out Hussein's blog that gets into the testing and the assessment that they did. They have posted a link in the chat. So go check it out. It's definitely worth a read because that talks about the testing that Trendyol did with Yugabyte DB versus other databases. Second, go look at Yugabyte DB's docs, right? So this is docs.yugabyte.com. There's a section under Yugabyte DB core called benchmark, right? Where we talk about different benchmarks that you can run, including TPCC, Sysbench, YCSB, and several others. We talk about large data sets, talk about how you can test scalability and so on. We also get into performance tuning, performance troubleshooting. So that's a great section if that is something that you want to do. And we definitely encourage that people actually go and do benchmarking against their own environments because each environment is different. You might have different requirements. So we strongly recommend that people actually go do benchmarking, post the results. If you want to go and have a discussion around it, get onto our community Slack and go and post your results and ask for help, ask for suggestions. We will have someone on the team come and help you. It's a great way for you to actually start getting into looking at what Yugabyte DB can do. There are two other sessions in this conference that I want to definitely point you to if you're interested in performance tuning and performance in general. The first one happened yesterday. So the title was Path to 100K Warehouses. This was by the Yugabyte performance engineering team, where we talk about how we achieve 100K warehouses on the TPCC benchmark with a 63 node Yugabyte DB cluster, right? A single cluster, 100K warehouses. It was awesome. And the engineering team actually talks about all the changes that they did in the product in order to hit that result, right? So this is fantastic. It's a deep dive into performance, definitely worth checking out if you're interested in that topic. The second session is happening right after this one. That one's called TPCC Performance Tuning and Best Practices. So this is, again, basically a way for you to get into performance tuning. So the session will get into how you run TPCC benchmarks, how you can fine tune it, things you can do to get a good run, and so on. So definitely check that out. That is happening right after this session. And again, if you want to get into performance and performance measurements, performance benchmarking with Yugabyte DB, the session right after this is a good primer. From there, get to our docs, go check out all the different benchmarking tools and suggestions that we have, and then go and run your tests, get onto the community Slack and post it there. We would love to hear from you. Okay, great thing for you to do if you're looking at evaluating Yugabyte DB. With that, thanks everyone for joining us. We will be moving to the Q&A section. So join us in the Q&A room for this track and look forward to seeing you there.